This lesson on horizontal stretch and shrink is going to be focused on finding a transformation rule for a horizontal stretch or horizontal shrink. And remember, shrink is sometimes called compression. Okay, so this is part 2 of our study on horizontal stretch, horizontal compression. And again, our focus here is to come up with a rule, a transformation rule for doing this. Now remember, in a previous lesson you learned that you're dealing with a horizontal stretch or shrink whenever you have this situation where you have y equals f of c times x. So where instead of f of x, you have c times x. So where the variable x is being multiplied by some constant. Okay, so that's going to be a horizontal stretch or horizontal compression. Now, let's talk about the idea of stretch and shrink. What does it look like for f of x to shrink or f of x to stretch? Okay, so we're going to look at this example. So we have this graph here, let's say. All right, so that's the graph, and let's call this function f of x. So we're going to call this f of x. All right, so this is our function f of x. And notice that on this function, we have this shape right here. And so it has this form. So you have these little segments. You have this horizontal segment, and you have this segment as well. Okay? So if I were to horizontally shrink, now remember, horizontal means going left and right. Horizontal, just like this. Okay? That means horizontal. So if I'm going to horizontally shrink this graph, then that means I want to take every point on this graph. I want to take every point on this graph and move it towards the y-axis. Okay? So remember, a horizontal shrink is where you take every point on this graph, on this function, and you moving it towards the y-axis. Okay? All right, so that's what that means. That's what a horizontal shrink means. And a horizontal stretch, so if you are stretching this horizontal, remember horizontal means this way. Remember, this is vertical, this is horizontal. A horizontal stretch would be where you're taking every point on this function and you're moving it away from the y-axis. All right, so you're moving it away from the y-axis. So every point is moving away from the y-axis. So when you move it towards the y-axis, your graph is shrinking. So that's a horizontal shrink. When you move it away from the y-axis, when you move your graph away from the y-axis where it becomes larger, so to speak, your graph is stretching. Okay, so you're stretching f of x. All right, and you're getting a new function. All right, a whole different function, has a different shape. All right, so let's write this down. So what I want you to remember is this. So when you are dealing, when you're dealing with a horizontal shrink or compression, okay, you are taking your function and moving every point towards, and I should say horizontally, towards the y-axis. Okay? So again, let's talk about this. So we have this right here, this function, and so every point is going to be moved towards the y-axis the same distance, okay? The same factor. All right, so move towards the y-axis at the same factor. All right, I'm going to talk about that idea of factoring in a little while, okay? All right, so the idea of factor, I don't want you to think that see where I have all these arrows? It didn't mean that these arrows represent the same distance, okay? It's not the same distance, it's the same factor. All right, so when you move this this point a certain distance this way, that distance is not going to be the same, but it'll be the same factor. Okay, so we're going to talk about that. So be careful. It's not that I'm moving it 3 units, 3 units, 3 units, 3 units. That's not what we're talking about. So we're talking about a factor. But the shape, the configuration of this figure is going to stay the same. It's just the shape's going to be smaller. Okay, so don't confuse yourself into thinking that you're moving each point the same distance. It's not the same distance. So don't say this is moved 3 units, this is moved 3 units, this is moved 3 units. That's not what that means. Notice I use the word factor. Factor. I use the word factor. So we're going to talk about what that means in a little while, and we'll come back to this if we need to. And the same thing here. When I stretch this, I don't mean that I'm stretching it 6 units, 6 units, 6 units, 6 units. That's not what that means. Okay? You're stretching it by a certain factor. So this could be 6, this could be 3, this could be 1.5. Okay? So that's what that means. All right. So we're going to try and understand what we mean by factor. All right. So again, the idea is, what do I mean by this factor? Okay. So when you have what we say here is that when you're dealing with a horizontal compression or a shrink, you are taking your function and moving every point horizontally towards the y-axis the same factor, not the same distance, the same factor. All right. So if I'm doing a horizontal compression, I'm going to take this point and move it over. Take this point and move it over. May not be the same distance. Okay. So don't think that these distances are the same. All right. And then horizontal stretch is where I'm moving it this way. All right. Now again, don't think that you're moving it away from the y-axis. All right. Now be a little bit careful when the point's on the y-axis. We're going to talk about that. So every point is being moved away from the y-axis, but not the same distance. All right. That's not what that means. So you're going to see in a little while what we're talking about. Okay. All right. So horizontal compression. You're taking every point, moving it towards the y-axis. You're moving it towards the y-axis. Not the same distance, but the same factor. All right, same factor. Okay. Horizontal stretch, you're moving it away. Okay, so you're moving it away from the y-axis. Again, not the same distance, but the same factor. All right, so let's write that down. So when you are dealing with, when you have a horizontal stretch, okay, when you have a horizontal stretch, you are moving each point on your function away from the y-axis by a certain factor. All right, factor. So remember, factor means something like 2 times 3. So 2 and 3 are factors. So think of multiplication or think of division. So just think in that way. So factor, multiplication, the idea of multiplying. Okay? All right, now let's look at this example. So I'm going to go back to this example we had here. All right, I'm going to go back to this example. I'm going to go ahead and erase those markings I made. Okay, so let's look at our function f of x. Now, I'm going to overlay this, and it's in green. I'm overlay this over this, and this right here, this function green, we're going to call it g of x. All right, so that's going to be g of x. And so what I want you to understand is this. I'm going to ask you a question. So is can I get the function g of x? So is g of x transformed by taking f of x and shrinking it or stretching it? So do I get g of x by by transforming f of x by shrinking or stretching? Do you think that f of x is shrunk or stretched to get g of x? What do you think? All right, so obviously you're going to say, well, the g of x looks smaller, right? Now it has that same configuration. See, the same configuration. See how the segments look? All right, so it is a shrink. All right, so what I want you to understand here is this. I'm going to write this down. So g of x, I'm going to put this right here. So g of x is obtained by shrinking f of x. All right, by shrinking f of x. And the question is, by what factor? By a factor of something, right? All right, so we're going to come back to this idea. Well, what is that factor? So whenever you talk about a horizontal stretch or a horizontal shrink, you're always going to talk about by a factor of, by a factor of, by a factor of. Okay, so that wording is going to be important when you talk about horizontal stretch or horizontal shrink, and that's going to help us with our rule, our transformation rule. Okay, so do y'all agree again that this right here is so to get g of x, I take f of x and I shrink it. Okay, so every point, I want you to see this. I want you to see this, that every point on this graph of f of x is being moved. Now remember a while ago we said that not by the same distance, right? So I want you to see this. Do you agree that this distance, when I take this point, move it here, that distance is 1, 2, 3, 4. If I take, let's say, I'm trying to find an easier point, well, there isn't any really, but if I take this point here and I move it to this, do you agree that's not the same distance, right? Okay, so I don't want you to think that those are the same distances. So that's why we said by a certain factor and not by the distance. So we don't move it the same distance, we move it by a factor. See how it actually decreases? Okay? All right, so you're gonna learn very easily, very quickly, what that factor is. Okay, and the same thing here. So I'm taking every point on this one and moving it towards the y-axis. Notice that these distances are not the same. All right, those distances are not the same. All right, so let's continue talking about this. Now, remember our idea here is to come up with a transformation rule. Okay, transformation rule. So this is considered a horizontal shrink. All right, so the way we describe this is this. So we say that g of x is obtained by shrinking f of x by a factor of some number. All right. Now let's talk about, remember that's a shrinking. So we know that when we take our function and we move every point towards the y-axis, that's considered a horizontal shrink. Okay, a horizontal shrink. And I should have said this a little bit better right here, so I need to be careful because remember in the previous lesson we talked about vertical shrinking. So g of x is obtained by horizontally shrinking. Horizontally, so I need to be careful. So that's a horizontal shrink. So make sure you put the word horizontal. So horizontal shrink. Okay, now let's look at this one. So we're going to talk about a stretch, a horizontal stretch. So let's talk about a horizontal stretch. Okay, so let's look at this diagram. And so I have two graphs on here. One's in black, one's in red. Now, the black function is going to be f of x. I'm going to call this f of x. Okay, and the red one we're going to call h of x. Let's call it a different function. All right, and so what I want you to understand is this that we're transforming f of x. So we're going to take f of x and we're going to transform it to h of x. And so do you see that every point, remember these are arrows, so it keeps on going. So do you see that every point on f of x, I'm moving it away from the y-axis horizontally. So you see this is going to be a horizontal stretch. So my function f of x is getting bigger. See that? It's becoming wider in this case. All right. So you get a horizontal stretch when you take every point on the y-axis and you move it away. I'm sorry, every point on the function and you move it away from the y-axis horizontally. Okay, horizontally, just like this. All right, and do you see that the distances are not the same, right? Each distance, horizontal distance, is not the same, but it's increased by a certain factor. All right, so all these points, there's some factor that allows you, and that's going to be our transformation rule. There's some factor that allows you to take each of these points and move it horizontally away from the y-axis to get our new function. All right. So what I want you to see so far, what I want you to see here is this. So h of x is obtained by stretching horizontally f of x by a factor of some number. All right. So but by a factor. Okay. And we need to figure out, well, what is that factor? That idea that factor is going to be important. How do we determine that factor? And it's very simple to do. Okay, now let's talk about our previous problem where we had this. And that's the one I want to focus on because I actually want to figure out, well, how do we determine that factor? So we're going to go back over here. So there's our two graphs. All right, so we're taking f of x and we're transforming f of x to g of x. So I'm taking f of x and I'm shrinking it by a certain factor. All right, so let's talk about that. Okay, so what I'm going to do is I'm going to take each of these points here, right here, and I'm going to label those points. I'm going to label the coordinates of those points. So f of x. So let's talk about f of x first. All right, so remember the whole idea is to come up with a rule. What is that rule? What is that transformation rule when we have a horizontal shrink or horizontal stretch? What is that rule? Okay, and that's going to tell us what the factor is. All right, so f of x, if you look at the points on f of x, so f of x, this point here is negative 6, 8. So that's a point negative 6, 8. Y'all agree? Okay, so I'm going to write negative 6, 8 for right now. Then we have the point, this point right here is negative 4, 3. Negative 4, 3. Okay. This point here is negative 2, 1. This point here is 2, 1. This point here is 8, 5. Okay, 8, 5. All right, and what I want to do is I want to look at this, and I'm going to write it down here for right now. So I want to graph g of x. So g of x is equal to f of 2x. So let's look at that for a moment. G of x is equal to f of 2x. Okay? So to get f of 2x, I'm going to transform f of x by looking at f of 2x. All right, so I'm taking f of x instead of f of x, I'm looking at f of 2x. All right, and that's going to give me g of x. All right. Now remember, when we began here, we talked about that when you have a transformation that's horizontal stretch or horizontal shrink, we have this thing here, f of cx. All right. So c in this case is what number? What's c in this case? C is 2. So that's going to be important in our discussion in a little while. Keep in mind that in this case, c is 2. C is 2. So remember, this is y equals f of cx. All right. So that's when we have a horizontal stretch or horizontal shrink. All right, so in this case, though, I want to look at this function here. All right, now listen carefully to what I'm about to do. All right, so listen carefully. So if x, let's say, is negative 3, all right, so f is negative 3, right? Okay, so if x is negative 3, then g of negative 3 g of negative 3 is equal to f of 2 times negative 3, right? Okay, just follow me. Just follow me. So g of negative 3 is equal to f of 2 times negative 3. But that's the same thing as f of negative 6, right? Well, do I know what f of negative 6 is? Yes, I do, because look, what's f of negative 6? F of negative 6 is what y value? 8. So f of negative 6 is 8. So what I found is this. So a point on g of x is negative 3, 8. And isn't that what this is right here? Negative 3, 8. Isn't that what that is? Let's see that. I'll see it. Okay. So this point here, negative 6, 8, negative 6, 8, when I transformed f of x, this point became what point? Negative 3, 8. So when I transformed, I'm going to go here and do this. So when I transformed, this point became what point on g of x? So that point became what point? That point became negative 3, 8, right? Negative 3, 8. So notice that the y values are the same, but what changed? The x values. The x coordinates changed, right? Okay, so listen carefully. Let's continue on, and you're going to see what I'm getting at. All right, now let's look at this one then. Let's look at this one. So we saw negative 3, 8. Now let's look at if x is negative 2, let's say. If x is negative 2, then I want to find g of negative 2. Well, g of negative 2 is equal to f of 2 times negative 2, right? But what's 2 times negative 2? Well, 2 times negative 2 is negative 4. So now all I got to do is find f of negative 4. Well, let's look. What is f of negative 4? What's the y value when x is negative 4? 3. 3. So this is 3. Well, I want you to see something. I want you to see something. Let's go here. What is this point right here? This point? Negative 2, 3. So this point transformed to what point? You understand? You see what I'm saying? This point transformed to what point? Negative 2, 3. So look what I'm doing. Let's go here now. Watch what's happening. So this point, when I did that transformation, that horizontal transformation, I got negative 2, 3. So notice the y values stay the same. What changed? The x. Continue on. Watch what happened. I'm hoping you're seeing what's going to happen with our transformation rule. If x is negative 1, this becomes g of negative 1, which is g of x is this, so that's going to be f of 2 times negative 1. But what's 2 times negative 1? Well, that's negative 2. Well, do I know what f of negative 2 is? Sure I do. F of negative 2, when x is negative 2, my y value is what? 1. My y value is 1. All right, I want to look at this point now. What is this point right here on g of x? That point is negative 1, 1. So this point transformed to this point, right? So negative 2, 1 became what point when I did the transformation? It became the point negative 1, 1. So I'm going to go here now and say, all right, well, this point became negative 1, 1. So again, I'm going to say it again because that's going to be important. The y values stayed the same. What changed? The x coordinates. All right. Let's look at this one. If x, let's say, is 1, let's find what g of 1 is. So g of 1 would be f of 2 times 1, which is f of 2. But do I know what f of 2 is? Do I know what my y value is when I go to my function f when x is 2? Yep, it's what? 1. So that's 1. So that means, now look, see that 1, 1? In this right here, 1, 1 right here? So what that means is this, that the point 2, 1, you remember we're taking every point on f of x and we're moving it towards the y-axis. So this point 2, 1 transformed into what point? 1, 1. So this point transformed to 1, 1. So notice the y values stay the same, the x coordinate change. It kind of makes sense, right, that the y values would stay the same from your experiences and from our discussions and previous courses. So whenever you move horizontally, in the y value the same to all, so So look, this is on the y-axis. This is 5. So I agree that if I were to plot points here, that all these y values would be 5. All right. So whenever you move horizontally, the y value stays the same. It's the x's that are changing. See, the x's are changing. Okay. Now, if x is, let's say, all right. So we did x. We did x is 1. Now, okay. So let's do 4. If x is 4 right here, if x is 4, I want to find g of 4. Well, g of 4 will be f of 2 times 4, so that's f of 8. And do I know what f of 8 is? Yep, f of 8, remember, is what? Is 5, right? F of 8 is 5. So that means this right here is going to equal 5. So that means this is 5. And look, what's this right here? This point is what? 4, 5. So this point, 8, 4, transformed to what point? 4, 5. So 8, 5 transformed to the point on g of x as 4, 5. So again, notice the y values are the same. Okay. Now, we know this. So this is going to help us in our transformation rule for horizontal stretch and horizontal shrink. We know, now remember, this is involving horizontal shrink, okay? All right. So we know this. Our rule, our function rule, is that g of x is obtained by looking at f of 2x. Many students think that what you do then is you multiply x by 2. That's not what's happening. So because look, I want you to see this. If I take this x coordinate right here, which is 2, and I multiply by 2, I get 4, right? So when you multiply each of these x coordinates by 2, it actually gets bigger. But what's happening here? And that's going to help us with understanding it also. So if I'm going to do a horizontal shrink, and the y values stay the same, so it's something about x I've got to do to it, am I going to multiply by 2 or divide by 2 in this case? You would divide by 2. So look, what's negative 6 divided by 2? So I want you to see this. Negative 6 divided by 2. Remember, the C is 2, right? C is 2. Y'all agree? Okay. So negative 6 divided by 2, because remember, C is 2. I get negative 3. Negative 4 divided by C, which is 2, and I get what? Negative 2. Negative 2 divided by C, which is 2, and I get negative 1. Okay? 2 divided by 2, and I get what? 1, your x value. Okay? So that's where these are coming from. And then 8 divided by C, which is 2, gives me 4. And that's where this is. So the rule is this. I'm going to go back to that rule, and we're going to talk about this a little bit more with when we do a stretch. But here's our rule. Let me go back to our page that dealt with coming up with this rule. So remember, I wanted to come up with a transformation rule, right? Okay? So we saw that when we're transforming our function f of x, every point on f of x transforms. Okay? Whether we have a horizontal shrink or horizontal stretch, does not matter. Every point's going to change because I'm doing a stretch or a shrink. We notice this, though. We notice that the y value stayed the same, right? 8, 3, 1. The x value changed, and the x value changed by a factor. So remember we used the word factor? Okay, so it changed by a factor, and that factor is C. That's that factor. That factor is C. So in this case, well, I got to be careful here. So it changed by a factor of C. I need to be careful with this because let me change that wording. I'll come back and change the wording because the factor is not really 2. The factor is if you look at this, negative 6 is negative 6 times a half, right? Negative 4 is negative 4 times a half. So I need to be careful. Negative 2 is negative 2 times a half. So remember, dividing by 2 means multiplying by half, right? All right, so be careful. When we divide by c, that's the same thing as multiplying by the reciprocal. So the factor, so when we divide by c, we are multiplying by 1 over c, the reciprocal. So remember, division, to change division, we change multiplication, we take the reciprocal. So the factor is 1 over c. So I need to be careful when I said the factor is 2. It's not really 2 here. It's actually a half. Because look, what's negative 6 times a half? Negative 6 times a half is negative 3. Negative 4 times a half is negative 2. But you're right. You are dividing by c. I agree, and we're going to talk about that. You are dividing by c. But when you use that word factor, don't say by a factor of 2. It's actually by a factor of a half. Negative 6 times a half. Negative 4 times a half. Negative 2 times a half. 2 times a half. And so 8 times a half. Okay? All right. So we're going to come back to that. If that confuses you a little, don't worry about it. We'll come back to it when we talk about stretching as well. So here's the rule. So the rule is this. So every point on f of x, transforms. So when the rule is f of cx, y equal f of cx, so it transforms to this. So remember, the y values stay the same, but how do we get the x value? We took the x value and divided by what? C. That's the rule. So the rule is that when you do a transformation, whether it's a horizontal or a horizontal stretch or a horizontal shrink compression, the rule is the y value stays the same. All you do is take the x value, divide by c. Okay? Divide by c. The idea of factor, though, you got to be careful. So when you say by a factor of, you take the reciprocal. All right. So I'm going to put this here right now. So this word factor, when we say factor, we say the reciprocal of c. So it's going to be the reciprocal of c. The reciprocal of c. So don't say by a factor of c. All right. We say by a factor of, and then whatever the reciprocal of c is. All right. So if I go back over here now, so g of x is obtained by horizontally shrinking f of x by a factor of, so remember, g of x, remember, is this. So I'm going to go ahead and write this. G of x is f of 2x. And remember, c is 2. So do I say by a factor of 2? No, you don't say by a factor of 2. You say by a factor of that reciprocal. What's the reciprocal of 2? The reciprocal of 2 is 1/2. So by a factor of 1/2. All right. So when we talked about this earlier, when we said that a horizontal shrink is where I take every point in f of x and move it towards the y-axis. Okay. So what that meant when we talked about it was that it was not the same distance, but it was a factor, by a factor. So if I look at this distance here, and this is what I need for you to understand as well. If I look at the distance from the y-axis to this point, that's 8 units. Okay, y'all agree? Okay. If I take half of that, then this is how many units? 4. That's what it is. So by a factor of a half. By a factor of a half. So this distance here becomes what distance? 4. If this distance, let's do this one. So this is the distance of 5. You see that right here? That distance is 5. So from here to here, that distance is 5. If I take half of that, so remember the factor of a half, right? What's half of that? 2.5. So that's 2.5 right here. If I look at this distance right here, this distance, so that distance here is 2. If I take half of 2, this is what distance? 1. All right, and same thing on this side. So do you understand what I mean by a factor of a half? All right, so if c is 2, you don't say by a factor 2, because if you say by a factor 2, you're really increasing it. You're doubling this distance. So this distance is doubled. This distance is doubled. All right, but remember, this is a shrink. So So with this, remember, many students find the horizontal stretch, horizontal shrink difficult to understand because it's not intuitive to what they would think. So you don't multiply x by c, you divide x by c, and your factor is 1 over c. Okay? All right. So it is a little bit more harder to understand for horizontal than it is for vertical. Okay, so let's talk about a stretch then. So let's look at a stretch. Let's get this one. I think we can do this one. So let's look at this one. All right. So do y'all agree that h of x is a stretch, right? Okay. And let me go ahead and write out that rule. So here's the rule for h of x. So h of x, you're going to take f of x and you're going to transform it to get to this. So we do know that this is going to be a stretch because we're taking every point and we're moving it away from the y-axis by a certain factor. All right. So let's call this rule. This is the actual rule. So it's going to be f of 1 half x. So f of 1 half x. So remember the other one was f of 2x. This one's f of 1 half x. Okay. All right. So we're going to do the same thing that we did for the previous problem, meaning that we're going to look at in terms of these points. Okay. So you'll see what's happening. Okay. So I'm going to go ahead and label and write some points down that are on f of x. All right. So we're going to go ahead and do that. And so I'm going to do it the same way I did the previous one. So we have f of x. All right, and on f of x, I'm going to use certain points. So we have negative 6, 6. All right, negative 6, 6. We have negative 4, 4, right? Negative 4, 4. We have negative 2, 2. We have 1, 1. Negative 1, 1, I'm sorry. Negative 1, positive 1, right here. Negative 1, positive 1. We have 0, 0. And 1, 1, 2, 2, and so on, right? Okay, so we have 1, 1, 2, 2, 3, 3, 4, 4, 6, 6. All right, so I probably didn't need all this, but I just went ahead and I just wrote all of them. And actually not all of them, because remember there are how many points on this graph, on this function? They're an infinite number, right? Okay. So let's look at this then. So let's go off to the side down here and say this. So I want to find h of x, and h of x is f of 1 half x. Okay? All right, so if x is, let's say, negative 8, I get h of negative 8. H of negative 8 is f of 1 half times negative 8. And what's a half of negative 8? Well, that is, f. That's negative 4, right? So I'm going to go to my function f, and so the question is, what's the y value in x is negative 4? So the y value in x is negative 4 is a positive 4. So this becomes negative 8, 4. Okay? So on my function h of x, do you see a negative 8, 4? Yeah, you do. Okay? You see a negative 8, 4. So what that means is that this point here, so right here, so this point here, negative 4, 4, transformed to the point negative 8, 4. Now remember in the previous discussion, the y values stay the same. What changed? The x value. And notice the x values are getting bigger, right? Okay, so that's the idea of that stretch. So my x values are getting bigger by a certain factor. Okay? Now you see this 1 half? You see this 1 half? So the question is, do I take half of this to get this, or do I multiply by 2? Do I multiply by the reciprocal? It's the reciprocal, right? So that's why it's counterintuitive. You think counterintuitive. So to get our rule, remember our rule was we take x divided by c. So here's my question. If I take negative 4, divide by c, remember c is a half, right? C is a half. So if I take negative 4, divide by half, do y'all agree? Do y'all agree? That's the same thing as say negative 4 times 2. So what do you multiply by? You multiply by 2. So negative 4 times 2 is negative 8. All right, so you take the reciprocal, that's your factor. So you're multiplying by a factor of 2. You're multiplying by a factor of 2, which is the reciprocal of 1/2. So the reciprocal of 1/2 is 2. So that's your factor. Always take the reciprocal of c. So c is 2. I'm sorry, c is 1/2. So the reciprocal of 1/2 is 2. So that's your factor. Okay? So dividing by half means the same thing as multiplying by 2. All right, so let's look at the next one. So suppose then we had x's, let's say negative 6. Negative 6. So then we want to find h of negative 6. All right, h of negative 6. So that becomes f of 1/2 times negative 6, right? F of 1/2 times negative 6, which is f of negative 3. Well, do I know what f of negative 3 is? Well, I didn't write it here, but I can go to the graph. What's f of negative 3? F of negative 3 is what? 3. So that's 3. And this was what, 4? All right. So that means this. That means that the point, I'm going to go ahead and put that here. The point negative 3, I'm sorry, negative 6, negative 3, 3. So the point negative 3, 3 became what point? Negative 6, 3. So look, negative 3, 3 became the point negative 6, 3. So how do I go from here to here? I double the x-coordinate. Okay? So the point here is this. What do you think this is going to be here? So negative 2, 2 becomes what point on g of x? Becomes a point negative 4, 2. So you're doubling x, right? So remember, to get this, you're going to say negative 2 divided by half, which is negative 2 times 2. I remember c is a half. So you're multiplying each of these by 2. So this becomes negative 2, 1. This becomes 0, 0. This becomes 2, 1. Okay? So those are your points on h of x. And I said g of x, this is h of x, sorry. H of x. So that's your point on h of x. All right. So if we go back to the rule, so the rule is, regardless if you have a stretch or a shrink, does not matter. The y value stayed the same. What changes? The x. To get the new x coordinate, you're going to take the x coordinate from f of x, and you're going to divide by c. All right. Now here's what we say. All right. So whether we move horizontally by a stretch or a shrink, we say this. So we say the graph of g of x is obtained, whether it's g of x, h of x, doesn't matter, but it's obtained by transforming the graph of f of x horizontally by a factor of, and remember the factor is always, and you always take the reciprocal of c. Take the reciprocal of c. So you're saying 1 over c. All right, so you say the reciprocal of c. Reciprocal of c. Okay? All right. So what we want to do now, is kind of review all of this, because it is a lot. Horizontal stretch and shrink, is not an easy thing to understand, but it is doable. You can get to that point. So what I want to do is this. I want to look at this, just kind of help us to kind of put some things together. So let's suppose, so these will be some problems, just a few problems. Suppose that we have this. Number one, the point -3, 2 is on the graph of f of x. Okay? All right. G of x is obtained by this rule. So G of x is equal to f of 3x. Okay? So f of 3x. So then the question is, the point -3, 2 on f of x becomes what point on g of x? That's the question. So the point -3, 2 that's on f of x, it becomes what point on g of x? So remember, g of x is f of 3 times x. So it's not f of x, because remember, g of x and f of x are not the same graph. You saw that in the ones that we did earlier. You saw that when we have a horizontal stretch or horizontal shrink, it changes the shape of the graph. It's not the same graph. It changes the shape. The figure looks the same. It's still like V, but the shape changes. Okay? So g of x, though, is f of 3x. All right? So first of all, you got to figure out what c is. So c in this case is what? C is 3, right? Okay. So then, remember, you got to remember our rule. So our rule says that whenever we transformed horizontally, so this is a horizontal, so this is a horizontal, so note, you need to know that this is a horizontal, and is it a stretch or a shrink? What do you think? All right, so remember this is 3, so think the reciprocal. What's the reciprocal of 3? The reciprocal of 3 is 1/3, right? So you're taking every x coordinate and you're multiplying by a third, which means you're decreasing. You're decreasing. So that's going to be a shrink. So this is a horizontal shrink. Okay, horizontal shrink. All right, so that's something you have to know. So this is a horizontal shrink. So to get the new point, remember the y value stays the same. So the y value is 2. And all I do to get that x coordinate right here, is remember our rule. Our rule is this. xy becomes x divided by c, y. So all I do is I take the x coordinate, -3, and divide it by c, which is 3, and I get -1. So that becomes -1. Okay? All right, number 2. All right, suppose that the point 7, 4 is on f of x, all right, and g of x is, let's say, f of 1/4 x. Okay, f of 1/4 x. Then 7, 4 transforms to what point on g of x? All right, so remember the y value stays the same, so the y value is 4, so it's going to stay 4. And so remember c in this case, what's c in this case? Note, c is 1/4, right? And so our rule is when we're dealing with horizontal stretch or shrink, our rule is that xy transforms to x divided by c, y. So I take the x coordinate, which is 7, and I divide by 1/4, right? You divide by c. So 7 divided by 1/4 means 7 times the reciprocal of 1/4, which is 4. So that becomes 28. So that becomes 28. All right, so the new point is 28, 4. 28, 4. Okay? All right, now one more thing, and this is what I'm going to ask you. Okay, number 3. Okay, number 3. Suppose that g of x is f of 1/5 x. Okay? All right. So g of x is f of 1/5 x. All right, so here's what I'm going to say. All right, so we know that this is going to be a horizontal. Now here's the question: is it a stretch or a shrink? So remember, you got to take the reciprocal of c to determine that. So the reciprocal of c is well, c is 1/5. The reciprocal is 5. So you multiply in every x coordinate by 5, which means that they move away from the y-axis. Okay, they move away from the y-axis. So this is a horizontal um, stretch. All right. So here's what I'm saying. The graph of g of x is obtained by horizontally stretching the graph of f of x by a factor of blank. Now, this is where some of you are going to make a mistake, and I don't want you to do that. So your mistake is going to be that you're going to say 1/5. Remember, guys, it's not you're not multiplying x by c. You're dividing x by c. So your factor is going to be, remember, factors think of multiplication. So this becomes 7 times the reciprocal of c. The reciprocal of a fourth is 4. Okay? So your factor is that reciprocal. So don't say by a factor of 1/4. You say by a factor of what? 4. So remember, it's always going to be the reciprocal of c. Okay? All right. So that, I think, may help you. I'm hoping that this idea is going to help you with understanding the idea that of the vertical stretch. I'm sorry, that horizontal stretch, what that means. So remember, these are not the same distances. They change by a certain factor. All right, and that factor is that reciprocal of c. So whatever c is, this factor that it changed by is the reciprocal of that. That's what that is. All right, so when you move away from the y-axis, that's a stretch. When you move towards the y-axis horizontally, that's a shrink. Okay, and our rule, if I can find it real quick, our rule, remember, is that whenever we transform horizontally or vertically, the point xy transforms to x divided by cy. Remember, the y value stays the same. Makes sense because you're moving horizontally. So whenever you move horizontally, your y value stays the same. It's your x's that changes. Okay? All right. And the other thing you got to remember is this, that factor. Don't make the mistake and say by a factor of 1/4. It's not by c. It's always the reciprocal of c. Keep that in mind. If you got to write it down several times. The reciprocal of c. So your factor is 1 over c. In this case, 1 over 1/4, which I can't find anymore, but is 4. Okay, the one we did earlier. Okay. So that's the end of this lesson. So go back and just kind of take all these notes and look at the video and get as much as you can from this.